Greetings. In this problem, we want to calculate the equilibrium constant for an equation, knowing it for some other equations that we can add to come up with the equation we want. In Gen Chem 1, we learned that energies were additive, okay? And here we've learned that equilibrium constants are multiplicative, okay? We also learned that if I write an equation backwards, the equilibrium constant becomes the reciprocal, okay? So here I have SnO2 as a reactant. Here I have it as a product. So I need to write this equation backwards. So I have SnO2 as a solid plus 2H2 as a gas, forming Sn as a solid plus 2H2O as a gas. And the K for this is equal to 1 over 0.14. Now, if this doesn't make sense to you, take a piece of scrap paper and write this K. And what you'll see is this times this squared is in the numerator, and this times this squared is in the denominator. Now, if you come over here, this times this squared are in the numerator, where here they were in the denominator, and this times this squared are in the denominator, whereas over here they were in the numerator. So they're just the reciprocal. So the value of K is simply the reciprocal. Now I've got SnO2. I need something with CO. I have this equation here, but it only has one of them. So I'm going to need two of them. If there were energies, we add them, but since they're equilibrium constants, it's 1.5 squared. That is, we multiply it by itself twice. We don't add them. So I'm going to do this sort of in two steps. H2O is a gas, plus CO as a gas, forming H2 as a gas, plus CO2 as a gas. And this K is equal to 1.5. But notice here I only have one CO, I need two. So if I added these two equations, the K would be this times this. If I wrote this equation again, it would be this times this times this. And of course, writing it again is the same thing as putting a 2 here, and a 2 here, and a 2 here, and a 2 here. And now this becomes squared. This is the common mistake. Students will multiply by 2. That's energy. They'll multiply it by 2, whereas really it's the K times K. Okay, now I want to add my two coupled equations to come up with the equation that I want the K for. And if this equation plus this equation equals this, then this K is equal to this times this. So I start off with the SnO2 as a solid, and I like to mark them off. Now I have 2H2. Notice that H2 was a reactant here and a product here, so it cancels. Now I have my H2O. Notice it was a product here and a reactant here, so it cancels. And incidentally, here it's in the numerator of the equilibrium constant. Here it's in the denominator of the equilibrium constant. When I multiply them, they cancel because they're over on top of each other. Now I have 2CO on this side, none on this side, so I have plus 2CO as a gas. And now what is left? I have Sn as a solid plus 2CO2 as a gas. And I double check that my equations are the same. They are. Therefore, K3 is equal to K1 times K2, which is equal to 1 over 0.14 times 1.5 squared. Okay, this was really this equation twice. And I now get out my calculator, and I have K is equal to 16. Okay? So be careful on this. In Gen Chem 1, we added energies. What you need to realize is equilibrium constants are multiplicative. And if I have coupled equations, the total equilibrium constant is the result of the multiplication of all the individual equilibrium constants that added up. Okay? I hope this makes it clear and helps.